All right, now, hello. Now we're going to be doing the next. We're doing this. This is your assignment here. We're going to be looking at this is SP14. All right, SP14. So be aware. That's what this is. The next one. Now we're taking this really slow because I want to make sure everybody's got this down like perfectly. This is really important stuff. I don't say that about everything. This is important. So we're now going to be doing. It's the same thing we just did. It's the same thing we did previously. However, you'll see instead of it being moles of compounds or moles of elements, it's moles of compounds instead. So basically, here let's do a few examples, and I'll talk about your work. So let's just do some examples here. The big difference between this and the previous work is that those are elements; these are going to be compounds. What does that mean? Well, let's say that we have 7.4 grams of H2O, and we want to find how many moles that is. All right, how many moles is that? Well, it's reasonably straightforward, but the thing is, the way you're going to handle this, you got 7.4 grams of H2O and you're converting to moles. Well, okay, let's look at our so we got our chart written on one. So remember, grams is right here. This is from the periodic table right here. This is the periodic table mass. So we're going from grams to moles. So we're going to go grams to moles. We're going to divide by the periodic table mass. The big problem, though, however, water. Is water on the periodic table directly? No. So what do? Well, you got to find the molar mass of water. So let's get the problem set up first. So we got 7.4 grams of H2O. All right. Remember, 1 mole of H2O, always 1 for the mole. Now, what number do we put here? That is the question. So you got to find the mass of water. So we're going to do the molar mass. So we're going to find the molar mass of H2O. So this is going back to those problems we did previously. Remember where you were like these problems where you were figuring out, you were adding up, breaking it down, adding up the different elements together. It's not meant to be that big of a challenge. It's just, so you got 2 H's, you got 1 oxygen. For H2O, you have 2 H's, 1 oxygen. The mass of hydrogen is 1.01. That's off this periodic table thing. Oxygen is 16. So that's going to be equal to 2.02 plus 16. That gives you 18.02. You're going to remember that one pretty solidly pretty soon. You're going to deal with water a lot. So the mass is 18.02. So this is the same thing that we did. The only difference is that now instead of it being an element here, it's a compound. So I'm going to do 7.4 divided by 18. And you get 0.41. And then the only thing you got to do is that this is moles of H2O. All right. So same idea. You're just going to be now taking these molar mass values and using them instead of just the single periodic table stuff. All right, that's the big difference. So in all of these, it's the same idea. The one thing that's going to get you, though, so one other example here. What if you were going to do this? Let's say that you have, start with, let's say we have 2.4 moles of carbon monoxide or hydrogen peroxide molecules. So you have 2.4 moles of hydrogen peroxide, and you want to know how many molecules of H2O2 is that? So now you see the word molecule. You're like, what the heck's a molecule? Same deal. You're just going to look at your little chart thing and be like, all right, molecules are down here, just with atoms. They're the same thing, just with atoms. So you're going to multiply by Avogadro's number. You'll notice that, again, this doesn't change. Doesn't matter what the formula is, whether it's hydrogen peroxide, H2O2, whether it's carbon, whether it's lithium, whether it's a glucose, it could be anything. It doesn't matter. It's always Avogadro's number that you're multiplying by. So you're just going to do 2.4 moles of H2O2. You're going to put moles of that down here. And the big thing you're going to do, you're going to write molecules. I always abbreviate molecules as MOLEC of H2O2 up here. So 1 mole, and then remember, you're multiplying by Avogadro's number. So you're going to multiply by that. So you're just doing 2.4 times Avogadro's number, which I have saved as A in my calculator. So that gives us, we'll say 1.44 times 10 to the 24th. So there you go. Those cancel. So that's the big thing for solving. That's the big thing for solving these, is that the only difference, depending on the setup. So if you're doing grams, you now are going to have to figure out the molar mass of the compound. So if you're given a compound, so like if you take a look at these problems, so like in this case, you got molecules, fine. So that's all just Avogadro's number. But then down here, this number 6, you've got grams of NH3. So when you do this calculation, you're going to have to say, all right, I've got, what is my mass of NH3? And you're going to have to go and figure that out. That's the big one. All right, that's the big difference. So it's pretty basic one-step stuff. Next week, we're going to get into two-step conversions, and we're going to also do volume. So next week, the big challenge is that we're going to be do 2 steps in one. We're going to go like grams, moles, to maybe atoms or something. Then we're also going to involve volume. By the end of this, you should be able to convert everything on the chart, no problem. But for right now, that's the basic idea.